Okay, let's talk about some important discrete distributions. Okay, first, and then we'll talk about some important continuous distributions. Okay, and then we'll basically see how to visualize and do all the results. And then we'll talk about law of large numbers and central limit theorem. Okay. Okay, so suppose I'm interested in basically binomial random variable. Okay, I want to actually figure out the probabilities associated with the binomial random variable. Okay, there are many examples that fits into binomial random variable. So suppose you are playing, or basically, it's a coin toss game. If you just toss this coin 20 times, okay, and you are interested in number of heads. Okay, toss a fair coin 20 times. You are interested in the number of heads. Then what is the distribution of this binomial? 20 half. Okay, or if I'll play Monty Hall game with you 20 times. Okay, Monty Hall game with you 20 times. You know that by switching strategy, you can win the prize by probability, with probability 2/3. Okay, so if I play this Monty Hall game with you 20 times, and I'm interested in number of times you win the Monty Hall game. Okay, what is the distribution of this binomial? 20 comma 20 by 2 by 3. Is that okay? Because the probability of succeeding in each game is 2/3. Is that okay? Fine. Okay. So let's figure out the PMF, the CDF, the quantiles, and so all those functions which are related to binomial. Okay. So you can actually, if you want to see the documentation related to binomial, you can put a question mark and put pbinom. Okay, and just run this, and you'll see the description. Okay, so there are actually 4 kinds of functions which are useful, and which are available in R. Okay, one is dbinom. Dbinom is for figuring out the PMF. Okay, probability mass function. Okay, pbinom is for figuring out the CDF, cumulative distribution function. Okay, qbinom is for the quantile function. Let's say if I am interested in let's say the inverse of the CDF. Okay, that's a quantile function. Okay, then we'll do some problems. Okay, don't worry about that. Okay, so how to get that? That is something that we can do using qbinom. Okay, and then finally rbinom. Suppose I'm interested in repeating this binomial experiment multiple times. Okay, and I'm interested in generating those values, random values, like for example the way we did for the coin toss. We toss this coin so many times. So if we generate random numbers from these distributions a few times, then, and we are interested in that particular sample, then what values we are going to get. Is that clear? Okay, so let's do that. Okay, okay, so suppose the experiment is tossing a fair coin 100 times. Okay, and suppose I'm interested in, so these are all comments. Okay, so you can always, I mean, it's helpful to write them, because later on if you want to access your file again, these comments, you can actually use them for your own understanding of what you have written in the next block of code. Okay, so probability that, let's say, so x is number of heads. Let me define x. So this is the random variable, number of heads. Okay, so notice that number of heads is binomial 100 half. Yes or no? Okay, if x is number of heads, then it is binomial 100 half random variable. Yes. Okay, good. So I'm interested in, let's say, probability that x equals probability that x is equal to 50, for example. I'm interested in that. Okay, So by the way, what is the expression for this? What is probability that x equals to 50 if x is binomial 100 half? 100 choose 50 into 1 by 2 to the power 100. Okay, so that is the value that I'm interested in. So for that I can use dbinom. Okay, PMF. Okay, so dbinom is for PMF. Okay, so let's just use this. So let's just keep this documentation in mind. Okay, dbinom. Okay, x is basically 50. Okay, number of heads is 50. Okay, and then what is the size? Size is 100, right? So we have to specify the parameters. Okay, 100. And what is the probability of success in each trial? That's half. That's it. Let's run this. Okay, that's the probability of getting 50 heads in 100 tosses of a fair coin. Is that okay? Clear to everyone? Is this clear? Okay. Suppose I want to calculate at once, probability of getting 45 heads, 46 heads, 47 heads, 48 heads, and so on and so forth, till 55, for example, 45 to 55. So what I can do is I can replace this by 45 to 55. Okay. So this is the way we can actually generate, uh, we can have multiple input values. And for all those input values, you can generate the output at the same time. Okay. So let's run this. Okay. And this is going to give you the probability of each of them. Okay, so this is the probability of 45 heads, this is for 46 heads, this is for 47, 48, 49, 50, 51, 52, 53, 54, and 55. Is that okay? Fine. Suppose you want to figure out what is the probability that the number of heads is between 45 and 55, then you can use a sum function on this. Just sum them up. Okay, and that's going to give you the probability that number of heads is between 45 and 55. Okay, so okay, let's just run this. Okay, and that's the probability. It's close to 73%. Is that fine? So if you toss a fair coin 100 times, the chances that you'll observe number of heads between 45 and 55 is close to 73%. Is that fine? Have you understood this? dbinom is going to give you the value of the PMF, probability mass function, at each of those points. Is that fine? Okay, right. Okay, so you can also do the same calculation using the cumulative distribution function. Okay, so this is something that we did using the PMF. You can also do the same thing using CDF. Okay, so notice that this can be written as probability that x is less than or equal to 55, right? This was 55. Okay, probability that x is less than or equal to 55 minus probability that x is less than or equal to 44. Do you agree? Yes or no? Can I do it like this? Okay, so in order to find these values, you can use CDF. There is a function for the CDF which is known as pbinom. Okay, dbinom is for the PMF, and pbinom is for the CDF. Okay, so you can use pbinom. So let's just do that, and let's figure out this value using pbinom. Okay, so pbinom 55, 100, half, minus pbinom 44 100 half. Okay, let's run this. Okay, you can see it's exactly the same value that you're getting. This is just the same thing, right? Okay, is that fine? So you can either use the CDF or the PMF. Okay, so to find these values. Okay, is that clear? Okay, let's try and answer a different kind of question now. Let's think about a quantile function. Okay, so what is a quantile function? So it's like, I mean, you have seen percentiles, right? I mean, so so you know that, so suppose I have 100 students in the class, okay, and suppose their grades are distributed, or scores, suppose their scores are distributed, uh, according to, let's say, binomial distribution, binomial 100 half, okay, and suppose I'm interested in the 90th percentile. So what is the 90th percentile? It's basically the score of the student below which 90% of the class is there. So basically the scores of the 90% of the class is there. So student who is sitting at the 90th percentile. So basically this is actually, we are interested in kind of the inverse of the CDF, if you really think about it, because so I'm interested in C such that probability that a randomly selected student from this class scores less than or equal to C is 0.9. Yes or no? Probability C such that a randomly selected student from this class scores less than, basically probability that is less than or equal to this particular score is equal to 0.9. Yes or no? That's how you can think about it. That's 90th percentile. Just think about it. So among the 100 students, 90th percentile is basically the score of the 90th student if you arrange the score in the ascending order. Is that okay? So if you randomly draw a student from this class, it's basically the score below which 90% of the scores are. Okay, fine. So I'm interested in C such that probability that X is less than or equal to C is 0.9. Actually, to be precise, for discrete distribution, let me give you the precise definition for the percentile, but I mean, this is true for continuous, okay, that you find C such that this is true, okay, but for discrete distribution, you want this to be true, okay. Probability that X is less than or equal to C should be greater than or equal to 0.9, and probability that X is greater than or equal to C should be greater than or equal to 0.1. Is that okay? That's the definition of 90th percentile. Is that okay? So including that person, everybody, including that person, everybody below him, including him, constitutes 90% of the class. And including that person, everybody, including him and everybody above him, constitutes 10% of the class. So this is exactly at the 90th percent. This person, is that fine? Clear to everyone? Okay, this is a precise definition for discrete distributions. Okay, so let's figure out the 90th percentile. Okay, so we are going to use qbinom for it. Qbinom. Okay, qbinom. I'm interested in what? So the first input is basically the percentile that I'm interested in, 0.9. Okay, and then of course then the parameters. Okay, which distribution is it? What is the score distribution? So I'm assuming that the score distribution is binomial 100 half. So 100 1 by 2. Okay, and that's it. Let's run this. Okay, so you can see it's 56. Okay, so the student who scored 56 is actually, below 56. 90% of the students are there. Okay. Is that clear? Okay, and it makes sense, right? I mean, it's just if it's a binomial 100 half random variable, of course. Okay, so if it's a binomial 100 half random variable, then it's very unlikely to see a lot of scores above 56 or 57 or something like that. In fact, we can just quickly verify this. Okay, we can verify this, that probability that x is less than or equal to c is greater than or equal to 0.9, and probability that x is greater than or equal to c is also greater than or equal to 0.1. So how do we verify this? So let's call this c. Okay, so you tell me, how should I verify this? Which function should I use? Pbinom. Okay, let's use pbinom c 100 half. Okay, let's run this. Did I just a minute? Sorry. Yeah. So you can see this is 0.90, right? Yes or no? Okay. I mean, actually, C was something else earlier, so that's why it gave me something else. But now that I've updated the value of C, so I'm getting this value. Is that fine? Okay. So C is this. Okay, and now if I run pbinom, I got 0.903, which satisfies this property. Is that okay? We can also verify that it also satisfies this property. Okay, this is something that you can do. 1 minus pbinom. Okay, and probability that x is greater than or equal to c is greater than or equal to 0.1. So I have to also include with this, because this will give me probability that x is strictly greater than c. Okay, so I have to also include in this dbinom. Okay, and let's run this, and this should be greater than 0.1. Okay, as you can see, this is also greater than 0.1. Is that fine? Have you all understood this? Any questions? No?
So was that /GEQ?
Huh? /GQ. Oh yeah, I'm sorry about that. Actually, what happens is that I use LaTeX a lot of times, so all the time, it's just, it just keeps on happening. Okay, sorry. Is that fine? Okay, so fine. Okay, so let's now just see the bar plot of the PMF. Okay, let's do that. Okay, fine. So what you can do is, P is, let's say, 0.5. Okay, let's see for a smaller n first. Okay, n is 20. Okay, okay. Now what I'll do is I'll create a data frame of probability values, and then I take their columns and and plot it. Okay, using kind of a bar plot. So what is a bar plot? So basically, it's a bar plot of PMF. Okay, what is a bar plot of PMF of binomial 100, binomial 20 half? It is basically going to give me vertical bars of length, which is exactly equal to the probability of those many heads. Okay, so that's what it's going to give me. Okay, so let's just quickly check that. Okay, so df. So I'm just naming my data frame df. You can put any name here, whatever name you think is going to be good. Okay, so the x values are 0 to n. Okay, and probs are, okay, what are the probabilities? That is something that you're going to get using dbinom function, right? Dbinom. Okay, so dbinom, and what will be the input? Input is this 0 is to n. Okay, And what else do you need in the input? You need uh, the size and the prob. Okay, so n and p. Okay, because I've already defined n and p, so I can use that. Okay, so this is going to create a data frame. Okay, let's run this. Let's check. Okay, let's print out the data frame. You can see these are the probabilities. Okay, it has two columns. X column is basically the x values, okay, and the d, and this is basically the corresponding probability values. Okay, so if you see something like this, e minus 0.7 over here, this is nothing but this number multiplied by 10 to the power minus 7. Okay, so similarly this number over here is this number multiplied by 10 to the power minus 1. Is that okay? Yeah. Okay. Okay, so now let's put the x values on the horizontal axis and the probabilities on the vertical axis, and let's plot kind of a bar plot to visualize the PMF of binomial 20 half. Okay, so what you can do is, you can use uh, the package ggplot. Okay, so of course there are two. First of all, you have to install the package. So if you haven't installed it, then you have to use install dot packages. I already have it, so I'm not going to install it. Okay, but you can do this. Okay, ggplot2. First do this, all of you. Install dot packages ggplot2. Okay, once you are done with this, just run this. Okay, install dot packages. Then you have to load the library. Okay, so there are two ways to load it. You can actually go to the packages and just look for ggplot2. Okay, so this is ggplot. Okay, so you can just put a tick mark over here. Okay, and that's going to load it. Otherwise, you can just simply run library ggplot2. Okay, let me just remove this. Okay, and let's just run this. Okay, it's automatically going to load it for you. Okay, so you can run it from here, or you can just, once it's installed, you can actually just click there. Is that fine? Okay. Okay, so once you have this, okay, then we can actually use ggplot function in the ggplot2 package to actually plot the graphs. Okay, so let me tell you like how to do that. Okay, ggplot. Okay, so what is the input? Again, if you want, you want to read the documentation, you can put a question mark ggplot, and that's going to give you the help related to the ggplot function. Okay, but I'm just going to quickly tell you this. Okay, so ggplot df. Okay, that's the input. The entire data frame that you have just created will be the input to this function, ggplot function. Okay, and then you can, in the aesthetics, you can define exactly what values of, so graph has a different characteristics, right? I mean, it has x values, y values, color values, and these are, so this is, aesthetics is something that you can use to define what values correspond to what. Okay, so on x-axis, I'll put the x values here of the data frame. On y-axis, I'll put the probs. Okay, so this is how you can actually tell R that this is what you want to do. Okay, you want to put x on x-axis. You want to map it to the x variable in the data frame. Okay, and y-axis you want to map it to the probability values in the data frame. Okay, and then you can actually tell, what kind of graph you want to make. Okay, what kind of graph you want to make. So we are going to make a geom underscore call, so we are going to make like columns bar graph. Okay, so that so you can just put a plus sign, okay, and tell that this is what you want to do, geom underscore. So you'll see there are a lot of options. Okay, so we'll just use geom underscore call. Okay, and then we can also, well, let's just run this first. Okay, okay, can you see this?
Yes.
All of you, everyone is able to get the PMF? Yes or no? Okay, good. So this is your PMF. Okay, and if you want to actually title the graph, you can actually use uh, you can actually use other features in the function. Okay, like for example, if you put gg title, okay, then it will give you an option to put a title of whatever your choice. Okay, so I'll put PMF of binomial 20 half random variable, or just simply this. Okay, let's run this, and it will just add a title to the graph. Huh? Is there a problem? Could not find, oh, gg title. Yeah.
Yes.
Okay, is that fine? Have you understood this? Okay, in fact, you can if you want, you can export, save the image as PDF. If you want to use in your paper, or wherever you want to use it, you can save it as an image and basically upload that image in your research paper, whichever paper you're writing. Okay, or an article. Is that fine? This is export. Okay, just save as image. Okay, is that fine? Okay, have you understood this? Okay. So I've also shared one document on the website. So if you want to actually revise some of this stuff, that has different examples than this one. Okay, then so I'll try and take different examples from the ones that are there in the document. I'll also share the file with you. Okay, so in case you want to review, what we did in today's session, you can always run the file. Okay, so what you can do is, I'll just tell you, this is where I've shared the document. So if you just visit econschool.in, okay, it's there in workshops. Okay, so this is the document. Okay, this has a lot of stuff. I'll keep updating this as well, with more stuff. Okay, so you can actually just have a look at it. Okay, and yeah, and there is also forum. Okay, the contents, I mean, it's something that are visible in Chrome and other browsers. I mean, it's not visible in Safari. I don't know why, but they'll be visible. I mean, if you just watch them elsewhere. Okay, and you also have access to to this particular forum. Is that fine?
Amit, sorry, I just missed it. Where do we get it in Econ School?
Yeah, econschool.in, just workshops. Okay, and you can also, I mean, you also have access to the forum, so you can also get it from the forum. So if you just
Okay.
click on with our workshop, so if you just click on this, you'll get the file there as well.
Okay, thanks.
No problem. Okay. Okay, so suppose you want to find the variance of binomial random variable, so how do we find the variance? Well, we can. So what is variance? So let's just find variance of x, which is binomial 20 half. Okay. So can you tell me what is the variance, by the way? So what is it if it's binomial 100 half? 5. Is that okay? 20 into half. So let's see. Let's find this using R. Of course, I'm just doing it because so that you also revise your probability. But I mean, this is something. Of course, R gives you a lot of additional power. I mean, besides these, you can actually find the variances of random variables which you are interested in. Okay, for which, of course, there is no closed form solution. You can also use R for that. Okay, but we are just using familiar distributions because it's just going to be easy to verify. Okay, so let's first find ex square. So let me name it ex square. Okay, so ex square is what? What do you do in ex square? How do you find ex square? Expectation of x square? Summation. So Lotus, use Lotus summation x square pxx. Okay, so how do you actually multiply a vector of x squares with a vector of PMF? So this is what you can do. Maybe let's just create the x values. Okay, let's say the x values are 0 to n, right? Yes or no? N is 20, so I don't have to again define n. Okay, and probs. Actually, I can also use the data frame. Let me just use that. Okay, I think that's going to be, because I already have the data frame. I have the probs and I have x value, so I don't have to do that again. So let me tell you how to access the column of a data frame. I think that's going to be better. Okay, so df x. Okay, let's just print this out. You can see that you are able to access the x column in the data frame that you've just created. Okay, yes or no? Okay, so dfx. Now what you're going to do is, if you want to find expected value of x squared, you take the square of them. Okay, so if you take the square of them and print it out, you will see you will get values from 0 to 400. Yes or no? Okay, now you multiply them by probs. Okay, so this is going to do a element by element multiplication. Okay, probs is also a vector which corresponds to the probabilities. Okay, it's going to give an element by element multiplication, and then you add them up. Is that okay? Because that's what expected value of x square is, right? Okay, let's just run this. Sorry, not probs, but df probs. Okay, let me run this. Okay, you can see this is what you're going to get. Okay, and now you sum this. Okay, that's expected value of x squared. Let's find out what this value is. Okay, it is 105. Is that fine? Okay, now you want to find the we also want to find expected value of x, right? So what is ex? You do the same thing, but instead of x square, you just leave it as dfx, and you'll get ex. Okay, so what do you expect here? Should be 10, right? Okay, and it is indeed 10. And what is variance of x? Variance of x is ex squared minus square of ex. Is that okay? Fine. And now you can print Vx. Always use, variable names which also make sense. I mean, of course, you have freedom to use whatever you want to use, but I mean, using sensible variable names will also help you understand and remember things. So is that fine? Okay. 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 So this was variance, and of course, you can, this is something that we did for binomial. In the document, you'll find an example for geometric. You can do it for anything. You can do it for hypergeometric, geometric, negative binomial. All the functions are there, and you'll always find 4 functions for each type. So like for example, if for geometric random variable, you'll find 4 functions: pgeom, dgeom, qgeom, and rgeom. Okay, so let's use rbinom now. Okay, so let's see how we're going to use rbinom. Okay, and then you try the geometric yourself using the documentation and using uh, the file that I've shared. Okay, fine. So generating an IID sample. So when I say IID, I mean independently and identically distributed. Okay, so it's like tossing a fair coin 20 times. That is generating an IID sample of size 20. Okay, from a coin. Okay, so by tossing a coin 20 times. Okay, so IID is like independently and identically distributed random variables. Okay, so the random variables are independent and all of them are identically distributed. Okay, all of them have the same distribution and all of them are independent. Okay, so that's what IID stand for. Okay, so generating an IID sample of size 100 from binomial 20 half random variable. Is that okay? Fine. From binomial 20 half random variable. Okay, so how do we do this? Okay, so we can actually use rbinom for it. Okay, rbinom. Okay, sorry, rbinom is a function. Okay, let's put these in X. Okay, so these are those 20 values. So let's just quickly check the documentation. Okay, rbinom. Okay, so you can see that the last 2 are again the parameters, and the first input is your what size of sample are you interested in. Okay, so I'm interested in basically doing this 100 times. Okay, so I'll put 100. Okay, and then second is n, third is p. Is that okay? These are the parameters. Okay, fine. I've already specified n and p, so I don't have to do this again. Okay, so let's just run this and print out the results. Okay, let's run this. Okay, these are 20 draws. Sorry, these are 100 draws from binomial 20 half random variables. Okay, these are 100 draws from binomial 20 half distribution. Is that clear? Okay, so okay, so let's just imagine that you have students. Suppose we have students in the class. Okay, their score distribution is binomial 20 half. Their score distribution is binomial 20 half. Okay, what that means is that they have scored between 0 and 20, all of them. Okay, and their score distribution is, let's say you did some estimation, you found that it is roughly binomial 20 half. Okay, now you actually conducted an experiment where you want to draw a sample of size 100 from this population. Is that okay? Sample of size 100 with replacement. So you have these scores, okay, which are binomial 20 half distribution, which follows binomial 20 half distribution. Scores are between 0 and 20. Okay, the distribution is binomial 20 half. So distribution means it tells you how many people scored, what proportion of people scored 10, what proportion of people scored 11, what proportion of people scored 12, and so on and so forth. So this is something that you get from the PMFs. Okay, so you want to draw a sample of size 100 from this. How do you do it? This is how you do it. Use rbinom, and you end up drawing 100 scores, okay, from this population, you know, from this score data, which is binomial 20 half. Is that okay? Please note that this is sampling with replacement because it's ID, right? So if you're drawing the first person, when you're drawing the second person, you keep the first person back into the population, then draw from there, because it's the same distribution that you're going to draw from in the second situation as well. Okay, so that's important. Is this clear? Okay, fine. Okay, so yeah, I mean, and if I ask you what is the mean of X, what do you think will be the average? What will be your guess? It should be around 10. Again, by law of large numbers, it's a sample which is of big enough size. It's 100 size. I mean, of course, it will not be exactly 10, but it will be close to 10. Okay, and every time I'm going to do this, I'll get a value different, you know, different from the previous one, but it will always be close to 10. Okay, the reason is again by law of large numbers. Okay, because you're doing this experiment over and over again from the same population, so the average of the sample will be close to the population average. Is that okay? Fine. So let's just do this mean X. Let's just print it out. Okay, should be close to 10, and you can see it's 9.71. Is that fine? Okay, you do this again, of course, you'll get a different value. Okay, you know, because based on, you know, who you are drawing, which 100 students you are drawing from the class, that it doesn't matter. I mean, it can be anything. You know, I mean, of course, you are doing it in your machine. I'm doing it in my machines. Of course, it will be different because we are drawing a different sample. Okay, is that fine? Okay, but it will be close to 10. Okay, and if you draw a larger sample, it will be even closer to 10. Okay, let's just draw a sample of size 100. Sorry, 1000 with replacement. Okay, you can see that it's going to get even more closer to 10 than it was before. Okay, you can run this again. Is that okay? Clear, everyone? Okay.